All right, guys, welcome to the breakdown video of our brand new furnace from Jorgen Harle Blacksmith. So we needed a new furnace for the stainless production line. As you guys know, we've been setting up this production line for a handful of months now. And I knew we were gonna need a forge, or a furnace specifically. We'll talk about the difference between a forge and furnace in a minute. But we needed a furnace that could reach 2150, which is kind of what we found to be the ideal temp for working with some of the stainless steels that we're going to be making our stainless Damascus out of. And you know, we've gotten forges and furnaces from other companies before. I needed something really big, really robust, and something that was super controllable as far as the temperature. And so I'm just doing a lot of research, you know, checking out all kinds of different builders online and different companies to work with, and wasn't really seeing anything I really liked. Then one day I ran across a post from Mr. Gabe Fletcher of Anchorage Forge, where he bought a furnace setup similar to this from this guy, Jorgen Harle. And I kind of jumped on it. I was like, hey, where'd you get that? That's kind of something similar to what I've been looking for. And he put me in touch with Jorgen. I started talking to Jorgen and kind of quickly realized that was the guy that I wanted to build our system. He's a wealth of knowledge in this. He's built forges for a very long time. He teaches classes on building forges and stuff like that. And he's been in the industry with all the glass blowing guys, all the big timers doing lots of glass blowing in large production environments. And he's real tight with those guys and spent a lot of time talking to them and working through this system that we're getting ready to talk about. So before we get into the nitty gritty, let's kind of go over some basic features here. The furnace overall chamber size is 36 inches long, about 14 inches wide, and 11 inches tall in the very center. Now you'll notice, well, you may not be able to notice very well, but it's actually an arch. So this wall goes straight up and then it arches over. So Jorgen spent a lot of time kind of researching and working through airflow dynamics of burners within inside of chambers like this. And one of the things that you really want is, of course, that burner to curl. We see that in the industry with other people making forges. Getting that burner flame to come in and curl really helps with the efficiency of the burn and the heating up of the furnace. But with these, the burners are actually slightly canted upward, because the point is we are trying to heat up this curved poured roof. Now this is a really thick poured piece. Yeah, it's 4.5 inches thick, and it's in several segments along the length of the furnace, but it is one solid poured piece. And these were poured by a company who specializes in refractory. And it was cured over a very long period of time at very high temperature, and it's turned it basically into concrete. And it's as hard as you can get. It will last a very, very long time, and it's super, super strong. But back to the burners. So the whole point of this is that the burners don't heat up your material. You see that in a lot of forges these days, especially cheap forges, is the burners are just directly onto your material to heat up your material. In a proper setup, that's not the point. The point of the burners is to heat up the refractory, and then the refractory heats up your workpiece. In our case, we don't want the burners directly on our work. That leads to disproportional heat, and we need a very even and concentric heat throughout the whole furnace and throughout the workpiece. So in this setup, it is specifically designed for the burners to be heating up this overarch in the furnace, and then that radiates the heat down into the rest of the forge. And I gotta tell you, as you'll see in some of our footage of when we had this thing running, it works phenomenally well. Very, very well done setup. I mean, Jorgen went through all the math and all the dynamics of how this operates and really created a system that is absolutely perfect. Front and back of this forge, it does have a hearth. We found that a hearth is super, super handy to have on a forge in a production environment. And so the hearth's front and back is just a metal steel tray, and it's got a perfect width here to fit a standard size fire brick. And so these we can slide over wherever we need. We can take them out and replace them whenever we, bang them up. Inevitably, they'll get banged up and need replacing. Let's move into the door system real quick. As a bunch of you have seen in our previous videos, kind of on Instagram and stuff, one of our copper furnace has a air-operated door. So it's a foot pedal that controls a valve to an air cylinder that opens and closes the door. Really handy to be able to walk up to it hands-free and do that. But we found that there's sometimes some issues, when relying on an air cylinder, an air supply, switches in the valve for the foot pedal. From time to time, we had stuff break down. And when that air cylinder is not working, the door doesn't open and you're kind of screwed. So we opted to go with a more mechanical design for this furnace. Of course, this is all still Jorgen's genius. And this has been seen before, where you basically have counterweights that are holding your door either in whatever position, up or down, and they're balanced so that you can stop and hold the door at whatever position you want. Very, very handy. Based on chains, and then you have these giant counterweights on either side. And then at the bottom, of course, he built in a canister that's removable that has a bunch of, I think it's lead shot or bolts or something in there. I actually haven't opened it to see what's actually in there. But the reason that you would want that is so that you could reach in there and you could pull out some of those, some of that shot, or add more to it to increase the weight of the door, or reduce the weight of the door based on when this eventually starts wearing. You know, the door is going to wear over time as it goes up and down, and as you fire it and cool and fire and cool, the door weight is going to change. So over time, we'll need to either add or remove weight from these door weights to keep it balanced. But very easy system. It's got a crossbar in front to keep the door all the way up against the forge, so it's not flapping open on you. Very, very easy to use. And again, I mean, it doesn't take anything at all. As you'll notice, in some of these areas, we actually did get a little bit of damage to the forge in shipping. We're not exactly sure what happened. It was crated. Jorgen did a very, very good job at packing this. In fact, I was phenomenally impressed with how well he did his packaging. But it does look like it got hit. The crate got hit at some point and rattled the whole thing kind of badly. Tore out some of the screws in the base. And some of the lining, some of the mortar work in here did crack and pop due to being in shipping and getting hit. So we are going to pop the lid off and redo a little bit of mortar in there just to take up some of the gaps that created during shipping, and just repair some of these spots that took a little bit of a hit from that negligent shipping company. But what do you expect? It's a shipping company. All right, so moving on, let's talk about the burner system. We'll move the camera over here, but to do a quick overview, this is a PID controlled forge through a Type R thermocouple, and I'll explain why that Type R is important. But basically, the thermocouple reads the temperature and gives us a digital output here, and we can see exactly what the temperature of the furnace is. An important factor on the location of the thermocouple. You know, you see guys kind of do this in their home shops to their own home forges, and you know, put them in different places. And the placement of the thermocouple is really important because you want to be able to get an accurate read. You don't want an indirect line of any burners or of any heat. And so a lot of time and mental effort went into figuring out exactly where the thermocouple needed to be installed. You'll see in a close-up shot here in a minute that Jorgen put it directly between the two burners on the left-hand side, sticking out on the straight, tall wall side. And it is recessed in the wall in an opened pocket. So that way the tip of that thermocouple, where the temperature is read, has plenty of room to heat up around it. So it's showing an accurate temperature read of the internals of the forge without the thermocouple actually sticking into the workspace, because thermocouples are expensive, especially the Type Rs. And if it was sticking out during production, somebody would hit it with a billet or a block of steel. It would get hit eventually, actually probably pretty quickly. And so we wanted to make sure that it was actually flush to the wall so that we didn't have that risk. And so opening that pocket around the thermocouple, with it being recessed, was a critical factor and something Jorgen thought of, and I would have never thought of that. It's genius and it works great. So on the front, we've just got a quick switch and a standard 110 volt plug that kind of runs the electricals on this system. And so just switch, system comes on, and you light it. All right, so here's the gas system on this furnace. Everything on this furnace is 100% American made, with an exception of this zero governance regulator, which is from Germany. But that was one of the things that I really wanted to be the case here when talking with Jorgen, is I wanted to make sure that this was sourced as much from America as possible. We're big on American made, and I wanted as much of it to be American parts as possible. Jorgen, of course, is based over in Washington State, and so he's local to America. He's not local to us. That is across the country from us, but I wanted to point that out. So what we've got here, this is a propane system. This is not natural gas. It is running on propane. Let's start at the top here. We've got our 2 burners coming down into a single tube. And in between it, of course, is our thermocouple. This is a Type R thermocouple. There are a bunch of different types of thermocouples out there. Type R is, I'm not a pro on this. From my understanding, it is one of the more robust types of thermocouples you can have. It is much more accurate. It is much more hard abuse taking. It still can't take a lot of abuse. They're still kind of fragile, but when you're talking about an industrial system and an industrial setup where it's important to have reliability for long term and not being worrying about stuff breaking down, Type R is what Jorgen really recommended. And it is not cheap. It drives up the cost, and we will get into exactly how much this costs here shortly. Type R thermocouple. This comes down to the PID to basically tell us what the temperature of the internal forge is. So coming down from here, we've got our proportional air mixer made by Eclipse. These Eclipse burners, Eclipse mixing tubes, are not made anymore. They are very hard to find and they're very expensive. I believe this one alone is about $3 grand. Starting in the back, we've got our Amatec blower. Now, Amatec blowers, very, very small, compact blower, but they pack a huge punch. You know, a lot of forges out there are run on a bunch of different types of blowers, but of course, you know, the kind of squirrel fan style blower is very, very popular. That is not near what we need when it comes to a system like this. So Amatec blower coming in through the bottom main pipe comes up to the Eclipse mixing tube. Before we get into exactly how this works, down here we've got our inline for the gas. We're running a 1/2-inch line all the way from our gas supply. Our gas supply is a low pressure gas system running on about a 1/2 PSI. You might think, wow, how do you run forges on a 1/2 PSI? Well, it has an immense amount of flow. We have a 2-inch manifold that feeds all of our forges. And with the right setup, you really don't need a lot of flow. So 1/2 PSI feeding the whole system, which the zero governance regulator actually takes down even further to just a couple of water column, a couple inches of water column pressure. And so the system really runs on very, very little gas. It just sips it. And that's the beauty of designing a system where everything is designed to work together. You can really drive up that efficiency on your fuel consumption. We'll talk more about that later. But gas comes in. We've got a standard valve here, normally open or normally closed. I can't remember which. I think it's normally closed. Basically, if there's no power on or we lose power, it automatically cuts off the gas supply. Standard thing, safety feature. Comes up, we have an on and off valve here, and then we've got our zero governance regulator. I'm not even gonna pretend to know exactly what that does. It has to do with the pressure of the gas. It kind of manages that to a very precise amount. But I'm not smart enough to know exactly what that does. This then runs into the Eclipse mixing tube. And here's where the real beauty comes. When this system gets up to whatever set temp you put in the PID, the thermocouple tells the PID, hey, you've reached your set temp, let's say 2000 degrees. It tells the system, analog style, not digitally, to slow down the speed of your fan, and it regulates the gas pressure and the gas flow at the same time. So you can have set your mix, you know, with a certain amount of dragon's breath coming out. You've set a neutralizing environment, not neutralizing, so you've set a no oxygen environment in the forge, and you got that little bit of dragon's breath coming out. You know, you've tuned it in right where you want it. And instead of the system cutting the gas off and letting the temp drop in the forge, or there's a couple of different ways guys have done it in the past in the blacksmith industry, this system automatically just slows down the speed of the fan, which in proportion brings down the flow of gas so that it starts to lower the temperature of the furnace without creating an oxygen-rich environment, which typically would happen if you cut the gas flow. Your air is still going in and you're creating a oxygen-rich environment, where in this system, you want a slightly fuel-rich environment inside the forge. And so that's where the system really shines. I really wanted a very precise, easily controlled environment that stayed exactly where we set it when it comes to how much oxygen and how much fuel and what that ratio is inside the system. Because obviously if you get scale developing inside when you're working stainless, that can be a big problem. And so we wanted that to be able to be maintained and controlled. And this system does it. And I got to tell you, when it's on and it hits the 2000 degrees, it'll go that 1 degree over and then comes right back down and it just pulses right there, that 1 degree window. And I don't think you could get it any tighter when it comes to temperature control. This is genius design. And on this proportional air mixer, you got a little needle valve over here, flathead screwdriver adjustment. That is the only place you need to adjust the gas on this system. That simply adjusts how much gas is being fed into the system, and you can balance your air to gas ratio right there. But then once you have that set at full temp, you don't touch it again because the system does it automatically. It brings the gas and air up and down as needed to maintain your temperature. So that's kind of a rundown on most of the system there. I know that's super complicated and there's a lot of moving parts there, and I am not a professional when it comes to these sort of systems. So I'm doing my best to kind of explain what's going on here. But these were all designed to work together as one cohesive unit and system. Huge shout out to Jorgen. He is a wizard when it comes to these sorts of things. And this setup is gonna save us an immense amount of money and time. Both of these burners are completely tuned to this whole setup. Jorgen makes his own burners, and they're running about 200,000 BTUs in this system. And so there is a absolute ton of heating potential in here, more than we'll ever need. But it just does that on very minimum fuel. Let's talk about fuel consumption real quick, actually, because a lot of forges out there, the good ones are doing about a 60 to 70% consumption rate on their fuel. And so that's how efficient they are. They're consuming about that much of the available fuel, and the rest is kind of lost, either out the doors or whatnot. This system, as it's set up, I believe it was somewhere in the high 90%. I would have to reference the sheets that Jorgen ran on it, but he ran all the analysis of the fuel consumption and the fuel efficiency within the system, and we're getting in the high 90% of consumption of the gas, which means we're not wasting any gas. Gas is money, gas is expensive, and this sort of system is not wasting any, almost not wasting any, and it's barely using any as it is. So based on our current gas usage, this furnace will consume a fraction of how much those over there combined. This one will use even less than all of our other systems combined. So very fuel efficient. That was another thing that it was on my priority list. It wasn't super high when having this designed. I obviously wanted it efficient, but I was not prepared for how efficient a system like this could actually be made to. And that's the benefit of working with a professional when having something like this made. So that's kind of an overview of the gas system, of the proportional air mixing tubes. Very cool setup. And one of these days we're gonna get Jorgen down here to Baker Forge and kind of probably do another video and have him really go in depth on everything here and why he did certain setups the way he did and why he uses certain parts. There's so much more there that I just am not smart enough to get into. The science behind it is crazy. So let's move on to the back door setup. It's a little different than the front door, and then we'll talk about cost. Okay, so back door system, we decided not to go with the same sort of lifting system that we did on the front door, because this furnace, where it's gonna sit and how we're gonna use it, we're gonna mostly use one side and not both. If this was gonna be out in the middle of the shop and people were gonna be working from both ends, that'd be a different story. But for us, it's going to be inside what you can't really see here, but it's gonna be inside a forge chamber system here that helps pull all the residual heat off the forge. So we don't really need to adjust the back door very often, but from time to time we would. So Jorgen came up with a great little setup here. He's got these rods, and the door can be manually just lifted to different heights depending on where you want it. The first level here gives you about, a finger's width gap. Obviously, with a system like this, you can't completely close it all the way. It has to have some room for air and pressures. Again, that's a little bit over my head, but it has to be able to breathe. So you can't close it up 100% all the way while it's running. So level one's got a little bit of a gap there. And then We've got upper ones where we can raise it higher and higher as needed. So if cameraman Waylon would come out from behind the camera, we're gonna actually lift this up to the next level and show you kind of how that works. On the side here, we've got these extra rods, just because obviously this is gonna heat up, and if you needed to lift it when it was hot, you can bring these out and get away from the forge. So you just lift it up. There's the top one. So that's all the way up. And then of course there's segments below it. We're gonna go ahead and take the door off, just to kind of show you exactly what the forge looks like, because the door kind of hides this upper piece. So we'll take that off real quick. All right, so door's off, and you can see right here, the big monolithic upper roof component. There's either 2 or 3 segments of that roof, and the way he's got those set up to interlock is really cool. You can sort of see again some of that damage from shipping. We are gonna have to fix that. We've got a bit of a gap here now, and we need to adjust. Wow, that's still real hot. We ran that over 12 hours ago, and it's still real hot. Actually, almost 24 hours ago. Anyway, so there's a little bit of chinking work and some relining we're gonna need to do to fix some of the stuff that was damaged during shipping. But you can now clearly see that monolithic upper piece, very, very thick. These are cast, as I mentioned earlier, and fully hardened at a professional industrial place that does this thing every day. It spends like 2 days, I think, in a furnace at like 3,000 degrees or 2,400 degrees, something like that, to full cure these bad boys. So they come fully cured and ready to go. Of course, we've got a hearth on the backside as well, in case we ever needed to use the hearth on the backside. Also, if we had long pieces extending out of the furnace, there's a hearth there as well. So, all right, so what's the difference between a forge and a furnace? Throughout this video, I probably called this thing both, because in my head they're kind of mixed up, but I tried to call it a furnace because it is a furnace. The definition of a forge is kind of an open hearth setup, kind of like a coal forge would be. That can be a gas propane setup, but basically if it's a non-regulated temperature, meaning it's open, there's no PID, there's no electrical control of anything, it's just an open burning forge, it's a forge. When you're talking about a closed chamber system that's running on precise temperatures with a temper regulation system in it, that's where it becomes a furnace. And so these things are specifically a furnace, and that's kind of the difference there. In my mind, in this industry, it's probably kind of interchangeable, but that's why I most of the time am calling this a furnace, because by definition, it is a furnace and not a forge. Even though you could call it a forge and you'd be technically correct. So, but that's the differences there. I just wanted to clear that up. All right, so cost. How much does this behemoth cost? I figured it would be great to show you guys exactly how much something like this costs. This is not something you're gonna see every day in the blacksmith shop. This is a very specialized, large-scale furnace for a very specific application. But I wanted to kind of just be transparent with you guys on what a system like this actually costs. So including shipping, we have $33,000 into this forge. It was completely built by Jorgen. We did not build any components of it. We kind of put some of the parts together once it got here. Some of it had to be disassembled for shipping, but he built it entirely. It is his design, his brainchild, and we wanted to really invest long-term. And so we knew something like this was gonna cost money. Industrial machines cost more money, than a home-built system. This is not something I could build, or any of us here at Baker Forge could build. This needed the mind and eyes and technique and skill of somebody who knows what they're doing. And so it cost $33,000, including freight shipping, to get it here from from West Coast. I think he's just outside of Seattle. So that's how much this whole system cost. And you might be thinking, holy crap, that's a ton of money. Why would anybody spend that much on a forge when you could just throw one together? Well, I think we answered a lot of that already in all the work that went into this. I don't know exactly how much time it took Jorgen to build it. I know a ton of time was around design work, because he had never put together a system exactly like this. There were some new things that were tackled, and he did a lot of research and talked to a lot of industry people in the glass blowing world. So he spent an incredible amount of time working on this, and we're gonna use it for a very, very long time. It is built to last. But you know, we wanted to be all American made. That drives the price up too. Components are not as cheap. Certain components are not as cheap here in the US as could be bought in like China or Japan and whatnot. All electrical components, you know, everything except that governance regulator was made in the US and US components. So we're supporting American companies and American people when we buy American parts. So, and some of these components are very expensive. Amatec blower, the thermocouple, the proportional air mix tube, you know, we're talking thousands of dollars just for one or two of these components. And then you start adding a whole bunch of these components all together, the price goes up. And so we really wanted to make that investment. The cost was something that we felt was worth it. And it definitely was based on what we've seen so far and on the fire-ins we've done. We're very excited to put some steel in this baby because as soon as that hammer is ready, this thing's gonna be churning out stainless Damascus. So we're gonna push it back into its slot here where it's gonna go. And it's gonna be fired up here very shortly, and we're gonna be starting to forge some steel on it. So thank you guys so much for watching this video. I know this was kind of a crazy in-depth look at this setup, and I kind of nerd out on this stuff. So if you want to see more nerded out videos on different tools, let us know. We'll do a long form video on some of these other tools and machines, kind of nerding out if you like that technical detail about how this stuff works. So anyway, thank you guys. Appreciate you. Make sure you click the subscribe button so you don't miss any future videos, and we'll see you on the next one. Peace.